Okay, so we've got a hyperbolic function here, 1 over 3x minus 1. Find the inverse function. So again, let's swap our x and y's. X is equal to 1 over 3y minus 1. Reciprocate both sides, take the 1 across, and it's a messy looking form of it, y equals 1 on 3x plus 1/3, but it does the job. Don't forget to change it to f inverse of x is equal to 1/3 of 1 on x plus 1. The domain and range, well, the domain and range are obviously determined by the domain and range of the actual function. So if we do a quick graph sketch of the actual function, we soon see that the range of that function is from 0 to infinity, and the domain of that function is from 1/3 to infinity. And so that'll give me the range and domain of the inverse function pretty quickly. All right. Again, a little bit of composite function work. Find the values of c and d such that f of g of x equals. So f of g of x, well, let's substitute g of x into f of x, and we put the x plus 5 there into the x squared term. Expand the terms, group like terms, we get x squared plus 10x plus 16. Factorize that, I get x plus 8 plus 2. Which means c is equal to 8 and d is equal to 2, or the opposite way around. We've got no information about whether c is bigger than d or anything like that. All right. State the maximal domain for which f of g of x is defined. So again, we need the range of g to be in the domain of f. Straight away, I'm going to go into and just list the key values. So the key bit of information is that domain of f. The domain of f, okay, I need x squared minus 9 to be greater than or equal to 0, which means I need this section. No, sure, different. I need that blue section of the graph, yeah? That's where the function is greater than 0. So x is greater than 3 or x is less than -3, which is what I've written there. So that's what I need the g of x function, the range of that to be. So I've got in green there the g of x function. So again, I need this function to be greater than 3, which might be that yellow section there, or to be less than -3. So the key values there, and you can see from over the left-hand side there, if I solve x plus 5 equal to plus or minus 3, the key values are at x equal to -8 and x equal to -2. All right. So if I go from negative infinity to -8, union -2 to infinity, that will give me the maximum possible domain, which not surprisingly, if we compare that to the actual composite function, -8 and -2 are fairly significant in terms of that function rule, aren't they? All right, explain whether or not f of g of x exists. So again, we need the range of g to be inside the domain of f, and R is not a subset of R excluding infinity, so it doesn't exist. Nice, simple one. Make sure you put the actual values. The rule for g of f of x, pretty straightforward, 1 over 2x plus 1. The domain of that, so the domain of g of f of x is going to be determined by the domain of f, and the domain of f is R except for 0. All right, quick question. All right, these ones here are often, not so much. I guess this one here we're going to need to expand, aren't we? So let's just start with the left-hand side. 4 times g of 2u, which is just 1 plus 1 on 2u, minus 1 plus 1 on negative u. So if I multiply the 4 in, multiply by -1 through, it makes that a positive there. Let's simplify the 4 on 2u to be 2 on u. 4 minus 1 gives me the 3. And now all of a sudden I've got a 2 on u plus 1 on u, which is 3 on u. So I've got that expression there. So if I take the 3 out the front, I get 3 times 1 plus 1 on u, which is 3 times g of u, which is what we're looking for. Happy days. What do we got? R except for 0, 3 on x minus 4. Find the inverse. So I feel like we did similar to these in our notes. Again, let's swap x and y. I'm going to get the plus 4 across first, aren't I? And then I'll take the reciprocal of both sides and then multiply the 3 over. So there's my y equals 3 over x plus 4. So there's my inverse function. I need to have a domain. To specify a function, I should have a domain. So the domain of inverse is the range of f. And the range of f, look, we could do a quick graph sketch. It's basically a 1 on x graph shifted down 4 units, isn't it? So there's my negative 4. So what are we going to do? At x equal to 1, say, I get 3 minus 4, which is negative 1. So I might go something like that. Yeah, that's my asymptote at y equal to negative 4. So the range of that particular graph is from negative 4 to infinity, which is going to be the domain of my inverse. All right, f of x. So substitute f of x into f of x. So 1 over x squared becomes 1 over 1 on x squared, which means we get 1 on 1 on. So divide by a fraction, flip it upside down and multiply, which means I just get x squared. Evaluate the inverse function, g inverse, if g inverse is the inverse of g. So g of x is in fact x squared. So y is equal to plus or minus root x if I rearrange. So the inverse function, given the domain of f of x is r plus, which implies the domain of g of x is going to be r plus as well. So we're going to take the positive square root. So g inverse of x is equal to the positive square root of x. And so if I substitute 4 in there, if I substitute 16 in there, I get 4. Short and simple, write out the rule for f of g of x. So substitute g of x into f of x. And so we get, oh, geez, I'm glad I've looked at that. Look at that. Substitute g of x into f of x. Might as well fix that up now. Substitute g of x into f of x, so I get 2x plus 1 squared plus 1, don't I? So 4x squared plus 4x plus 1 plus 1, 4x squared plus 4x plus 2. Well, hopefully we've got it right that time. All right, quickly, let's just have a look at these half a dozen multiple choice questions. Again, to find the inverse, so we shouldn't have too many problems with that, hopefully. So if we rearrange, we get our x squared plus 4 on 2, which reduces us down normally to 2 or 3 options. So we've got 3 options there. So the difference between each of those 3 options is the domain that we've been defined over. So we have to think about the range of that original function. And the range of that original function is from 0 to infinity, which is going to give me the range of the inverse. So that makes D the answer. It took me a while to do this one, I've got to say, simply because we've typed the question wrong. So check your notes. It's actually x cubed minus 3x squared plus 3, not 3x, which means if we sketch that graph, it's 1 to 1. Okay, its turning point happens to be there at x equal to 0. So the largest value of a we can have is 0, because after that the function is no longer 1 to 1. So a is less than or equal to 0 there. If the function h equals f plus g, then the domain of the function, the domain of the inverse function. So f plus g, if we work it out, is given by x squared minus 3x plus 3. But don't forget that if we have a sum of functions, the domain of that sum is the intersection of the domains, if you like. So that function is just defined for 3 on 2 to 5 because that's all g is defined for. Yeah. So that addition or that sum of functions has got a domain of 3 on 2 to 5. And so if I substitute 3 on 2 to 5 into x squared minus 3x plus 3, I end up with an interval of 3/4 to 13, which is D. Which of the following is not true? Again, this one and question 7 are ones you could possibly use your CAS for and just sort of define the functions, write down the rules and just see. But I think when we've got x squared, we're going to have troubles when we have an x minus y and an x plus y. So x minus y, f of x minus y is x squared minus 2xy plus y squared. Clearly, we're missing that 2xy term. So D is going to be the answer there. Again, find the inverse. Again, identify the range from -3 to infinity. So that sort of tells me it can only be these bottom two, just purely on the domain that's been given. Again, rearrange our function, bring the 3 across, reciprocate both, take a square of both sides. I'll get 1 over x plus 3 all squared, which is this one. All right, so D is the answer there. Question 7. This one was probably best done on a calculator. And you can see there, so if I define the function 5 minus 2x and then type in the expression, the calculator will generate. Okay, and so whilst it's not obvious that they're not equal, straight away on the left-hand side, there's no x squared terms or anything like that. Whereas if I expand the bracket on the right-hand side, I'm going to get x squared y and xy squared and things like that. So clearly it's not 5 minus 2x. And then in fact, if I scoot down to 1 minus x, we can see I get 1 on x plus 1 on y equal to x plus y over xy. If I cross multiply, I will in fact get x plus y, or sorry, technically I'll get y plus x over xy, which is the same as x plus y over xy, to get a common denominator on the left-hand side. So C is the correct response there.